Welcome back, class. Thank you for joining me for our next notes video. Today we're going to do a little concept bite. So before we jump into the next section, we are going to do a little review on properties of exponents. Now, all of these are from your exponential algebra class back in the ninth grade. However, a lot of these rules are going to come into play in section 4. So we're going to take a step back. We're going to review just some of the basic properties of exponents to make sure that you can be successful in section 4. So you can see I provided a table for you of all of the rules. So remember rules like when you take anything to the 0 power, it equals 1. When you're dividing, you end up subtracting your exponents. When you have a negative exponent, you end up flipping its location in the fraction. When you're multiplying, you end up adding exponents. When you're taking a power of a power, you multiply exponents. So these are all the rules that are going to be coming back that you need to know for section 4. So I've constructed some examples here to show you what you can expect to see. So in our first example, this is a multiplication problem. So in this multiplication problem, the first thing I'm going to do is I'm going to notice these numbers, 5 and -3. Well, this is a multiplication problem. So you multiply the regular numbers that you see. So I'm going to multiply those numbers to give me -15. The next thing that I notice is now I have this a to the 3 times a to the -4. And remember, when we are multiplying, we end up adding the exponents. We end up adding 3 plus -4, which gives us an a to the -1. However, we're not quite finished yet because if you end up with a negative exponent, remember that's not the end of our story. So this negative exponent here, what that means is we're going to have to move that a to the denominator where it can have a positive exponent. So that -1 will shift to a positive 1. And of course, you really don't have to show that it's to the first power. So if you want to just call that a, that is totally fine. But now, only that a had the -1 exponent. So what that means is that -15 stays on top. It doesn't have to move with it. Only the thing with a negative exponent actually needs to move. All right, let's move on to the next one. So we have -4x to the -3, y to the 5th squared. All right, so what I'm going to do first is take that squared to everything, okay? So this is a power of a power now. So kind of consider distributing that power of 2 in. So the power of 2 goes to my -4. Well, -4 squared is 16. That 2 also goes to my x to the -3. Now, power of a power. When you take the power of a power, you end up multiplying the exponents. Then again, power of a power, you multiply your exponents. All right, so I've taken care of that power of a power. Now, the next thing, after doing that, I notice now I'm left with a negative exponent. So I'm going to move that x to the -6 downstairs where it can have a positive exponent. Nothing else has a negative exponent, so that means everything else can stay on top. And that is going to be my final answer. Now, moving on to the next one. So again, this is a list of powers of a power. So, however, I also noticed that s to the 0. So that's one of our very, very basic rules. S to the 0 is just 1. So I'm actually just going to cross that off because multiplying by 1 doesn't really do anything. So I'm just going to ignore that. So I'm going to take that power over power and send it to everything. So we get 2 to the negative third. Power of a power, so I'm going to multiply those exponents. I get r to the negative 9. And again, power of a power, negative 5 times negative 3 is a positive 15. All right, now this time I have two things that have a negative exponent. So that means I have two things that need to move downstairs to get a positive exponent, and that t to the 15 can stay put. My last thing to simplify this is when you have a number to a power, there's an easier way to write it. So that 2 to the third, well, 2 to the third, hopefully you recognize by now, is simply the number 8. So I'm going to write it as such. If you have a number, don't leave a number to a power. Just write what that is. All right, our bottom two examples. So for these, we are going to be using our division property. So what the division property says is you can subtract exponents. When you are dividing, you actually end up subtracting. So the 4 has nothing dividing it, so it gets to stay. Now I look at the a, so because the top one doesn't have an exponent, remember that means it's kind of a secret 1 sitting there. So a to the first divided by a to the 5, 1, take away 5. Well, 1 minus 5 is a negative 4. So really that's saying we have an a to the negative 4. Well, just so I don't end up with a ton of steps, I want you to consider that a to the negative 4, that negative means it's going to end up straight in the denominator as a positive. Now, the other way you could think of that is you have a 4 extra in the denominator. So the 1 cancels on top, but you have 4 left on the bottom because there were more there to begin with. Either way you want to think of it will work out just perfectly. But just make sure that you're aware, no matter what way you think of it, when the number is higher in the denominator, that's where the exponent ends up. B to the 6 divided by b to the first. Well, 6 minus 1 leaves us with a b to the 5. C to the 3 divided by c to the 3. Well, when you have anything divided by itself, it actually just cancels off. So that's c to the 3 divided by c to the 3 is just gone, removed from our expression. Now, to take this a step further, let's look at our next one. So the next one starts pretty similarly. However, now you have to take the whole thing to a power. Well, what I would do first is I would clean up inside the parenthesis first, okay? Clean up all those variables, then take everything squared. So, let's see what's happening. So that 3 over 5, well, it can't reduce, so it just ends up having to stay there. X squared divided by x to the first. Well, x to the 2 divided by x to the 1, 2 minus 1 leaves me with an x to the 1. All right? Y to the first, because there's nothing written there, divided by y to the negative 2. Well, this one is a little bit tricky. Be very, very careful with this, all right? So 1 minus negative 2. Well, subtracting a negative is the same thing as adding. So 1 minus a negative 2 is actually a y to the 3. So just be careful when you're working with those. If you subtract a negative, just make sure you're following it properly. Now z to the 5 divided by z squared. 5 minus 2 leaves me z cubed. And then I have that whole thing squared. And again, that whole thing squared, what that's going to end up meaning is that 2 applies to everything. So 3 squared gives me 9. X to the first squared, multiply the exponents. Y cubed squared, multiply the exponents. Z cubed squared, multiply the exponents. And it also distributes to the bottom. 5 squared is 25. So thank you so much for joining me. That is actually going to wrap up this little concept bite, this little review of all the stuff from Expo that hopefully you remember moving into section 4. So again, I thank you for joining me. Make sure you have all of this written down. And then I'll see you in class to continue our practice work.